So, as students, today we will discuss about a few problems based on the capacitors. I hope my screen is clear. You see, this is the problem they given in this. A parallel plate condenser is filled with the two dielectrics as shown in the as shown in the diagram. The area of the plates is given as a meter square, and the separation is in t meters. The dielectric constant are given as K1 and K2 respectively. Its capacitance in farad they ask. Means whenever they given these kind of diagrams you see here the distance is same in both the cases, distance is same here. But they are placed side by side means your area becomes A by 2 and A by 2. This you should consider as two capacitors, and they ask equivalent capacitance if it is point A and is the point B. We just connected one battery here. Means this is suppose we are giving lower potential, we are giving here higher potential like this. Means these are the two capacitors we have, and both the capacitors positive plates if you take they connected together each other, and the another one is connected to the another plates are connected to the negative terminals at the higher lower potential of the battery here. Okay, now the equivalent diagram we can write here. So we have two capacitors. These are the two capacitors we have, and these two are connected to the point A. So we're giving here higher potential, and here we are given negative charge or the lower potentials, and this is given as point B. Now we just consider as this is one capacitor, this is another capacitor. It's having dielectric constant K1 and it's having dielectric constant K2. And the area of the two plates, if you take area of the first plate becomes A by 2, and this is also A by 2. Thickness, there is no change. We can write the thickness is same T only. T. Now we have the formula C1 is equals to, when we are placed with the dielectric material, C1 equals to K1 into epsilon naught area A by 2 into D. So C1 becomes K1 by 2 into this is C naught. Why? Because epsilon naught A by D. If you want C naught formula, we have epsilon naught A by D is the C naught. And similarly, if you take C2, the C2 we can written as K2 into epsilon naught A by 2 into D. So this also becomes K2 by 2 times of C naught. Now positives connected together and the negatives connected together means it is a parallel combination. So parallel formula we have Cp equals to C1 plus C2. Now the equivalent capacitance is equals to C1 is this is and C2 is this. So if you can write C naught by 2, if you take common, it becomes K1 plus K2. So if they ask equivalent capacity dielectric constant, K1 plus K2 by 2 into C naught. C naught we can write epsilon naught A by D. But in problem, thickness is given as T. So we can replace with that T. Now the correct option, see the correct option what we have? Parallel combination K1 plus K2 by 2 into T. Now see the second problem. In the second problem, if you take, we can use the previous formula. So here A by 2 and this is A by 2. Now the equivalent capacitance we can write C equivalent is equals to K1 plus K2 by 2 into C naught. So in problem they given C naught value is 10 microfarad. So C P equals to K1 is given as 2. This is 4 by 2 into 10 microfarad. So this is becomes 6 by 2 into 10 microfarad. So answer equals to becomes 3 times. This is 30 microfarad is the correct answer for this problem. I hope it is clear. 30 microfarad is the correct answer for this. Okay. So we can use the previous problem formula as a reference for this problem. When the area is divided, we just assume that both the capacitors are connecting in parallel. So parallel formula we have C1 plus C2 when we have two capacitors. We'll go for the next one here. Two electric constant K1 and K2 have filled with between the plates of the shown. What will be the capacitance of this, they ask. So what we have the answer for this seal. Now you may have some confusion here. So see the diagram here, distance is divided. So distance from here to here, if we take, it is not area. Distance we can take as d by 2 and d by 2. This capacitor area is A. So if you take this is C1, this is C2. Now we have the formula C1 equals to K1 into epsilon naught A by D. D means it will go to the numerator. It becomes 2 K1 times of C naught. Similarly, C2 equals to K2 into epsilon naught A by D into 2. It becomes 2 K2 times of C naught. Now these two, whenever the capacitors placed one above the another, means like if you give the previous problem, if you give this is the higher potential, this is the lower potential. This is negative, this plate is positive, this is negative. So here the capacitor plates are connected positive, negative alternatively. When the capacitor plates are connected positive and negative alternately, that combination we can consider a series combination. In series capacitor series formula we have CS equals to C1 C2 by C1 plus C2. Then it becomes 2 K1 into C0 into 2 K2 into C0 by C1 plus C2 means we have the common 2 C0 is common. It becomes K1 plus K2. So numerator C0 get cancelled. One time C get cancelled. So CS equals to we have 2 K1 K2 by K1 plus K2 into C0. C0 value we have epsilon naught A by D. Epsilon naught A by D. Okay, so this is the way we can solve this problem. Then we can, what is the correct option for this? This is the option D is the correct answer we come. Okay, options we check it because I give the solution here. So then we for next one. So move for the next one. So the three capacitors are connected. The capacitors are connected of 5 capacitors are as shown in the adjacent diagram. The potential difference between A and B means we just assume that there is one battery of 60 volt. We just draw the diagram like this. So the potential difference between this given as 16 volts, then the equivalent capacitance between A and B and a charge on 5 microfarad capacitors they ask. Now, first we have to find out what is the equivalent capacitance of the given diagram. So it is an easy problem. Now see here. So this point and this point means we are connecting one wire here. So the equivalent diagram I will write here. See, this is 12 microfarad capacitor. Now see, from here to here, there is no capacitor. From here to here, there is no capacitor. Along this wire, there is no capacitor. So I will drag this wire on the top of this and the phi one. And if you see here, we can drag down. Means the equivalent diagram is like this. So this 10 will go to the up. This is 5. This is 9 microfarad. And this is connected to the 8. And now this and we can take it as V. So we have one battery of voltage given as 60 volt. Okay. Now see the diagram. This is 8 microfarad. This is 5, 10, 5, 9. All these three, 10, 5, 9. All these three are connected in parallel. So parallel means formula what we have 10 microfarad plus 5 microfarad plus 9 microfarad. It becomes 24 microfarad. So this is the capacitance of the middle one. Now if you want the equivalent diagram, we can write here 12. So this is an equivalent diagram we have. Okay. This is 12 microfarad. This is now 24 microfarad. This another one is 8 microfarad. Now they ask what is the equivalent capacitance between A and B. All these three are connected in parallel series. And series formula we have 1 by CS equals to 1 by 12 microfarad by 1 by 24 microfarad plus 1 by 8 microfarad. So total LCM is 8, 12, 24 means we can take 24 microfarad is LCM. So 12 twos are, 24 ones are, 8 threes are. So it becomes 3, 4 to the 6 by 24. So 4 ones are, 4 six are. So equivalent capacitance between AB equals to, this is 6 fours that get cancelled 24. So it becomes 4 microfarad. So Q equals to CAB into V. Why? Because all are counting in. So total charge is equals to 4 into V, how much? 60. So total charge is 24 microcoulomb. Now check. Now 24 microcoulomb means here also 24, but here whenever it will come 24, and we should take. So we have the answer along this they ask. So answer will come this option D will come the answer. We can find out the individual charge on that charge 24. 240 is divided into the three parts. So what is the charge means we have to find out the charge and it will comes as option D will come the answer. Yep. Next. See, this is one of the easiest problems. So again, this C will go to here and this C will come to here. Now the equivalent diagram we can write. So all these three connecting in parallel. So CAB equals to C plus C plus C. So CAB equals to 3C. So answer is option B. Next. Now, this is the one of the typical model and easiest model also. Whenever they ask equivalent capacitance, we should connect one battery here. So the plates which are connected directly to the positive terminal or negative terminal of this cell, we should give the both the sides are positive. So this is positive I because I connected to this positive here. So this is also positive. Both the sides we should give positive like this. And now see the plate B is connected to the negative. So here it is negative and the other side also negative. And again it is come to the negative. This is negative. As we know that a parallel plate capacitor means we should have one positive plate and one negative plate. So this is one capacitor, this is one capacitor, this is one capacitor. If you see the diagram, all positives are connected together, all negatives are connected together. Yeah. So the equivalent diagram, if you want, we can write this. So this is C, this is C, this is C. Yeah. So the equivalent capacitance between CAB equals to C plus C plus C. It becomes 3C. They ask in terms of the parallel plate capacitance formula 3 epsilon naught A by T. Okay. So option B is the correct answer. Next, see they given one diagram here and they ask here the charge and the potential difference across the 4 microfarad capacitor. Now see the diagram. So here we have the battery of 300 volts. These two are connected in parallel. These two are connected in parallel. So parallel means we have the formula Cp equals to 4 plus 4, it becomes 8 microfarad. Okay. In the equivalent diagram, we can write 20 microfarad. Now it is connected and it becomes 4 plus 4, it becomes 8 microfarad. Then we have one more capacitor, that is 12 microfarad capacitor. So these two are connected to the 300-volt battery. 300-volt battery is there. So first, if you calculate the charge, then no need to go for the potential difference in Joseph. We have only one option with the one charge. So to find out the charge, we should all these three are connecting in series. So equivalent capacitance 1 by CS equals to 1 by 20 plus 1 by 8 plus 1 by 12. Okay. So what is the LCM here? Can you tell LCM means here? So 25 volts, and what is the potential difference across the 4 volts battery also they ask. So 4 volts battery we can take, if you take this is V1 and this is V2 and this is V3. So they ask V3. Why? Because these two are in parallel means here also V3, here also V3 only. Now we have to find out what is the voltage across and what about the charge also. Just a minute. So 28 and 12. So if you calculate, it becomes CS equals to, okay. CS of doing the calculation part, it will becomes 120 by 31 microfarad will come. Yes. Then after charge, Q is equals to formula Q equals to C into V. C is 120 by 31 into V, how much they given 300. Micro is there, micro means becomes 1161 microcoulombs will come. This is the total charge. Now the charge on the 4 microfarad they ask. So charge in series charge is same, but 4 they're connecting in parallel equals to 1161 microcoulomb by 2. So it becomes 580 microcoulomb. So check the options with 580 microcoulomb. We have only one option. Okay. Then after potential difference, they ask. So potential difference across this is potential difference across four capacitor means this is 580 by 4. This is equals to 145 volt. So option 4 is the correct answer. Okay. So why? Because this is the way we can find out the answer for this particular problem. And go for the next one. See the next problem. Two capacitors, each of capacitors connecting in parallel. The system is connected series with the third capacitor 12 microfarad. So this is a just problem. Two capacitors of two are connected in parallel. This is connected in series with the third capacitor 12 microfarad. The equivalent capacitance they asked. Take this is point A and this is point B. This is 2 microfarad and this is 2 microfarad. So 2 they're connecting in parallel, so it becomes 4 microfarad. Now if they're connecting in series, formula C1 C2 by C1 plus C2. The system connecting series with the third capacitor 12 micro. So it becomes 4 into 12 by 4 plus 12 becomes 16. So 4 ones are 4 fours are 4 ones are 3. This is 3 microfarad. Okay. This is correct answer. Next, see the next problem. A 4 microfarad capacitor connected to the a 4 microfarad capacitor connected in parallel to the another. Means take this is C1 and this is C2. Both the condenser then connected in series with 8 microfarad and capacitor quantity. 4 and 8 connected in parallel. 4 and 8 connected in parallel. Both the condensers are connected in series with the 12 microfarad condenser and charge 20 volts. Then what is the charge stored and the 4 microfarad capacitor asked? So what is the problem you see here? So just a rough diagram. So we have two capacitors, 4 and 8. These two are the capacitors, 4 and 8. And these two are connected to the another capacitor, 12 microfarad. All capacitors are microfarad. And they given to the voltage 20 volts. Now what they ask, charge on the plate of 4 microfarad capacitor ask. First, these two are connecting in parallel. So it becomes 8 plus 4, 12. So this is one capacitor 12. This is one capacitor 12. And these two are connected to the voltage 20 volts. This is 12. This is 12. Now see here. 12, 12 means both the capacitors are equal, so they will share the voltage equally 10 volts. Means here also voltage 10 volts, here also 10 volts. The charge formula Q is equals to C into V. So C into V means how much it is. Here C is 4 micro, or if you want, this is 4, C is 4, and V they given as how much? In this branch, voltage is 10 volts. So it becomes 40 microcoulombs. So answer is option B. Yep. Next. A capacitor having the capacitance C charged to the voltage. So next problem C, 10th problem. Capacitor having the capacitance C is charged to the voltage V. Then it is removed and connected in parallel with another capacitor which is uncharged. Uncharged means V2 we can take it as 0. V2 equals to 0. So initial charge if we take before connecting Q1 is equals to C1 V1 and the given V2 equals to 0. So Q1 equals to we have C into V. So common potential if you take equals to C1 into V1 by C1 plus C2. Why? Because here V2 is equals to 0. This is the given removed connected parallel with the another identical capacitor means it becomes QC. So it becomes V by 2. And the new charge they ask, new charge how much here? New charge how much? So Q2 is equals to common potential you can find out. So V by 2, Q is equals to C by 2. So the new charge is becomes CV, means it becomes CV by 2. Next, this is also one of the important relation and problem also. This is balancing Wheatstone bridge. In current electricity, let us consider this is P, this is Q, this is R, this is S. We have the condition P by Q equals to R by S. So P by Q how much here? 6 by 12 equals to 9 by 18. This is 6 ones are, 6 twos are, 9 ones are, 9 twos are. So we can remove this capacitor, 24 microfarad capacitor. Now how this diagram is changed means this diagram will change like this. Like this diagram will change like this. Means this is 6 microfarad, this is 12 microfarad, and this is 9 microfarad, and this is 18 microfarad. Now these two are connecting in series. These two are connecting in series. This I am taking as C1. This is C2. C1 formula C1 C2. This is 6 into 12. By 6 plus 12 it becomes 18. 6 ones are 6 threes are 3 ones are 3 4. So it becomes 4 microfarad. Similarly, C2 means 9, 18. 9 plus 18, it becomes 27. And ones are 9 threes are, this is 6 microfarad. Now these two are connecting in parallel. So CAB equals to C1 plus C2. It becomes 4 microfarad plus 6 microfarad. It becomes 10 microfarad. So answer is option 4. Yep. Next. A 4 microfarad capacitor, 2 microfarad capacitor has the potential across the two ends is 200 volts. When it is disconnected with the battery and another uncharged capacitor disconnected by with the battery and then another uncharged capacitor is connected to the parallel, then the potential difference becomes 20 volts. Then the capacitance of another means C. This is the problem we have. Uncharged means V2 is equals to 0. We have the common potential formula C1 V1 plus C2 V2 by C1 plus C2. In problem, the common potential they given as 20 equals to C1 is 2 microfarad into V1 is they given as 200. And this is V20 means this part becomes 0 by C1 plus C2. So we want 2 microfarad plus C2 equals to, this is 21s are 20 tens are. So it becomes 20 microfarad. So C2 is equals to 20 microfarad minus 2 microfarad. It becomes 18 microfarad. This is the answer for this problem. Okay, next. So next one, if you see the resultant capacitance between A and B. So we have to come from this capacitance. 333, they connected in series. 333, they connected series in sequence, it becomes 1 microfarad. Identical capacitors connected in series, so it becomes 1. So the equivalent diagram we can write here. This is A, this is 3, and this is 2. Now it becomes 1. Now see, 1 and 2 connecting in parallel, it becomes 3 microfarad. Okay. So I will write the equivalent diagram. This is 3 microfarad. This is 3. This becomes 3. And this becomes 3. This is B. This. Now see. This is 3. This is 3 microfarad. This is the given as 2 microfarad. Sorry. Okay. This is 3 microfarad. Now again, these three connected in series, it becomes 1 microfarad. This is given as 3 microfarad, and this is also the given as 3 microfarad. Now the equivalent diagram, if you take, this is 3. Now these two are connecting in parallel. So this is 3 and this is 3. This is A and this is B. This is 3 microfarad. This is 3 microfarad. And this is 3 microfarad. So all are containing in series. Series identical capacitance formula, capacitance value by number of capacitors. Capacitance value is 3 microfarad, number of capacitors is 3. So it becomes 1 microfarad. So answer is option 1. Now this is one of the typical problem. If you see, we can go for in one of the corners of person. First, This diagram, we can make it as simple diagram. Right, this is A, so this is C. Make it as that is one. Now see, these two are connecting in parallel, so it becomes 4 microfarad. So 8 and 4 connecting in series. 8 and 4 connecting in series means 8 into 4 by 8 plus 4, 12. So 4 ones are 4 threes are. It becomes 8 by 3. So we have a capacitor here, becomes 8 by 3 microfarad SSB. Then you see here, we have one capacitor that value is 1 microfarad. Coming to these two are connecting in series. So 6 into 12 by 6 plus 12, it becomes 18. 6 ones are, 6 threes are, 3 ones are, 3 fours are, 4 microfarad. So this total value is equals to 4 microfarad. 4 and 4 connecting in parallel, it becomes 8. 8 microfarad. Now we see the 1 and 8 connecting in series. So this value is 1 into 8 by 9. The equivalent capacitance we can write, this is C, this is A, this is one capacitance, and this is one more capacitance given as B. This is 8 by 3, this is 8 by 9. Now these two are connecting in parallel. So 8 by 3 plus 8 by 9, 9 LCM, 3 8 is 24 plus 8. 24 plus 8, it becomes 32 by 9. Now this is connected to this in series, but it is given as 1 microfarad. Means 1 by 1 equals to 1 by C plus 32 by 9. So 1 by C we want. It becomes 1 minus 9 by 32. So it becomes 32 minus 9 by 32. 32 minus 9, it becomes 23 by 32. So everything is in microfarad. So answer is 23 by 32 microfarad. Okay. So that's all for today. So we'll discuss remaining things in next class.